lesson 1.2 is the topic of absolute value. So we're starting to, build it up a little bit more. So we're going to be talking about what absolute value is. And absolute value. Now, I'm not going to ask the question, but whenever I ask the question, what is absolute value? People are, it's very common for people to say, oh, well, this is what an absolute value equation looks like, which is true. This is what an absolute value equation does look like. And from here, you know that there are two values that could possibly be x. X could equal +7, and x could equal -7, because the absolute value of +7 is 7, and the absolute value of -7 is 7. One thing I forgot to mention, of course, is that these vertical lines mean absolute value. When you see this, it means take the number and drop the sign. So the absolute value of positive or negative numbers will always be the number itself. Okay, but that's what that is. Now, the question is, why is there an absolute value symbol that gives us just the number instead of the direction, either it's negative or positive? And for that, we need to look at the number line. This is what's called the number line. It's a very important concept. I really cannot emphasize how amazing and wonderful it is to represent something on the number line, because it's visual and you could see it and understand what's going on. So I'm going to create a number line, and you know that the numbers to the right of 0 are positive. I think you all kind of know that. And the numbers to the left of 0 are negative. And when we talk about the absolute value of 7, we are saying, well, here's 7. Here's -7. And we're not interested so much in, a sign number. A sign number. Let's talk about what a sign number is. A sign number is a number that has magnitude and it has direction. So when we talk about a sign number, the reason sign numbers were created, because then we could not only talk about just numbers, but we could talk about what direction. If it's negative, it's going to be in this direction. If it's positive, it's in that direction. So, that's what we're talking about. But when we're talking about absolute value, we're just talking about absolute value is the magnitude of a sign number. We could just say a number. Absolute value is the magnitude. So you could see that the absolute value of, we don't care about the positive. All we care about is the number itself is 7. The absolute value of -7 is 7, because we don't care if it's positive or negative. We just care about the magnitude of the number. So that's absolute value. And this is called an absolute value equation. And today we are going to take a look at absolute value equations. Anybody have a question so far? Okay, let's take, let's say this was our first question. Because, we actually solved the problem. But let's take another example down here. Solve for x. Now, I want to do this, so don't try this on your own. I have plenty of problems for you to try on your own, but right now, I want to just take a look at this. So, what we're saying here is that, within these vertical lines will be either a +8 or a -8. We've sort of couched it by saying, well, it's 3x minus 4, but in reality, what's in here will either be a +8 or a -8. Therefore, from here, we go to 3x minus 4 equals +8, and 3x minus 4 equals -8. That's what this means. This means that the number, whatever is inside, can either be the +8 or the -8. And instead of solving one equation, we now solve two equations. So here we go. And they're usually, pretty straightforward. 3x is equal to 12. X is equal to 4. And over here, 3x is equal to -4. And x is equal to -4/3. And those are the two answers to this question. When we take this number and substitute it back into the original equation, we will wind up with either a positive or a -8. Well, probably the positive version, because here was the negative. Let's just take a look at that for a moment. So 3x minus 4 is equal to 8, and let's substitute 4. So 3 times 4 minus 4 is equal to 8. 12 minus 4 is equal to 8. 8 is equal, well, the absolute value of 8 is equal to 8, assuming, +8. So that works out fine. Okay. And now let's look at the negative version. So 3x minus 4 equals negative. The absolute value equals, well, that's not true. That's not true. The absolute value can never be negative. It's what's inside the absolute value that could be negative. So that's what really I intended to do. It's, it's this becomes, well, it could be -8. Well, let's see if it is. 3 times 4/3. -4/3. Minus 4 equals -8 with a question mark on top there because we don't know. But as you can see, the 3's drop out. You get -4, -4, we think is equal to -8. -8 equals -8. And that checks. So there's your check. So wait a minute. Okay, that's it. Let's keep it in the absolute value for a minute. If you keep it in the absolute value and you break it down like this, you get -4, -4 is 8, the absolute value of that works out. See? That's your check. That's your check. These are, two possible ways of checking it. Is by first, doing it the way you did it before over here. But the better way of doing it is to actually do it in the absolute value symbol to see if it actually works out. That's how you solve and check an absolute value problem. And I'd like you to do this problem. I don't know if these are in the book or not. I just, make these, I'm just making these up as I'm going along. But here's a problem I'd like you to try. I have 3 problems that I'd like you to try. So first, look at this one. And I'll give you a couple of minutes.
Professor Allen, I have a question.
Right.
So I just wanted to clarify. So we're essentially looking for X before we could plug it in to find
Yes, you're looking for X. Yes, solve for X. So from here, one of the things I didn't do up on top was to rewrite the problem. So we should do that first. Yeah, this looks like this doesn't great. Let's change that to a 1 that looks like a 1. Okay, so from here we go in 2 directions. We go 2x minus 1 equals positive 3. And 2x minus 1 equals negative 3. That's the next step. And from here, you solve the equation. X can equal 2, positive 2. And X can equal negative 1. These are the 2 answers. Now, this is usually optional, but if you wanted to do, and this is the check, this is not actually part of the problem, but if you wanted to determine if this actually worked, you would say, okay, let me substitute the values. Let's see if that works out. So you get, all right, positive 2 times positive 2 is 4, minus 1 is 3, and 3 is equal to 3. Fine. The absolute value of 3, see, this becomes a 3, but I shortcutted it because it was kind of easy, just 4 minus 1. You could see that's equal to 3. This next one is going to be a little more challenging because the answer came out to negative. So now I'm taking this one and substituting it in there. This was the first one. This is the second one. Okay, so what do we get? We get negative 2 minus 1, we think, is equal to 3. The absolute value of negative 3, well, we know that the absolute value is the number without the sign, so this becomes this, and there's your check. Any questions? Now, when you're solving a
Professor?
question, final.
Yes, so for the check, we always put the 3 as a quote unquote positive number and not 3 on one side and negative 3 on the other side. I'm not sure if that was clear.
Not completely.
So for the check, for the first one, yes, the 3 that we are checking for is always the one that's in the equation. It's never 3, positive 3 on one and then negative 3 on the other.
Oh, no, 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 no. This is,
Okay.
this is really what you're doing. Like, this is really what you're,
Okay.
I did it in both places, because I wanted to just try it in both places, but this is really what you're doing.
Okay.
these
All
two
right.
things.
Sounds
Yeah,
good.
yeah, okay.
Thank you.
I got it, I finally got it. Anybody else? Oh, actually, this is from the, what is this, problem 3? So this is from the book, and it's, problem 1M. I don't know what page it is though, but it's 1M in the homework. If you were to look at the workbook, this is where it's from. Here's the, but that's not important. Here's the problem. And the object in this problem is to isolate the absolute value. In other words, get rid of this, get rid of this, get it all away so that all you're left with is what we were left with on the other side, which is the absolute value equals some number. Here's the problem. I'm just writing it over again. Keep the original. As you know, I like to keep the original problem. Now let's do things. Now the idea is to isolate the absolute value. So step 1 is to get rid of the 5. Get rid of the 5. If you divide it by -3, then you're dealing with a lot of peculiar fractions that can be very difficult. So this drops out, and you get -3 times 2 minus 6x equals -15. That's where we are now. Now we want to divide both sides of the equation by -3. You get rid of the 3's, and you still get the absolute value of 2 minus 6x equals 5. That's what you need. You need this number to be without the negative. If it had a negative, then the answer would be you can't do this problem. Now, at this point, you're going in 2 directions. You're going 2 minus 6x equals +5, and 2 minus 6x equals -5. That's what's underneath here. What's underneath here is either a +5 or a -5. And you do -2, -2, -6x equals 3. Uh-huh. Why did I say uh-huh? Because I see that x equals -3/6, but you know what I'm about to say. This has to be simplified, so x is equal to -1/2. And that's one answer. And here, -2, -2, negative 6x equals negative 7, negative 6, negative 6, x equals 7/6. Those are your two answers. Obviously, there's going to be a challenge when you have to actually check them and put the values back in. But we're going to do it. We're going to, see how that works. We should, we should take a look at that. Okay, so over here, again, write the original problem. Substitute for x. I'm not using parentheses, because I'm just gonna do that. I think it would be easier. Okay, so the issue here now is, this thing right here. See, it's not easy when you have to substitute fractions, but we're a pre-calculus group, so 1/2 of 6. Absolute value of 2. Now this negative and that negative becomes positive, and 6 times 1/2 is 3 equals 5. And the absolute value of 5 is equal to 5. Okay. And of course, 5 is equal to 5. And that works perfectly. And I'm looking at it, it worked, so I don't have to go that crazy checking it, because it looks like it'll work out pretty perfectly. The negative times the negative is a positive, and 1/2 of 6 is 3, and that's good. Okay, now the other one we'll do over here, which is the again, rewrite the original equation. And the absolute value of 2 minus 6 times 7/6. I don't want to use parentheses, because they'll get in the way when we're multiplying the fraction. So I'm getting rid of that. And just putting 7/6 equals 5. Okay. Alrighty, so, when you're doing, this is how you simplify that. Absolute value of 2 minus 7 equals 5. Yeah, this looks pretty good. 2 this is a positive 2 and a negative 7, which is a negative 5. It's the absolute value of negative 5. And the absolute value of negative 5, of course, absolute value of negative 5 is 5. 5 equals 5. That's it. There's the complete problem from beginning to end.